What up, your boy C. Rizzy coming at you with Unit 9, Lesson 1, Translations. Our essential question, how can you change a figure's position without changing its size and shape? And our objective is to identify what is rigid motion and to find translation images of a figure. So you can change the position of a geometric figure so that the angle measures and the distance between any 2 points of the figure stay the same. This is what rigid motion is. So there's a lot of vocabulary that goes along with this lesson and this chapter. What is a transformation? What is a preimage? What is an image? What is rigid motion? What's a translation? And what is a composition of transformation? All of these vocabulary terms should be in your notes. So a transformation of a geometric figure is a function or, quote, mapping that results in a change in the position, shape, or size of the figure. So when you play dominoes, you often move the dominoes by flipping them, sliding them, or turning them. Each time you do this, you're doing one of the basic transformations. So a domino flips, a domino slides, a domino turns. These all have very geometric transformation terms. In a transformation, the original figure is known as the preimage. The resulting figure is the image. So the first figure is the preimage. You then do the transformation, and you get the image. Some transformations, like the dominoes, preserve both distance and angle measures. To preserve distance means that the distance between any 2 points of the image is the same between the corresponding points of the preimage. To preserve angles, it means that the angles are all congruent to each other. A transformation that is said to preserve distance and angle measure is called rigid motion. So another way of saying rigid motion, it preserves both size and shape. Okay, so does the transformation appear to be rigid motion? In our first image, the figure only was reflected or flipped or however you want to look at it, but the preimage and image is exactly the same. They're congruent images, so yes, rigid motion was preserved. In B, the preimage and image, they look to be about the same size, so also, yes. The only time rigid motion is not preserved, for instance, is if I have a triangle and then I have a bigger triangle. Okay? In this case, no, rigid motion isn't preserved. So when you transform a figure, or move a figure, or flip a figure, okay, there's arrow notation. And prime notation, used with like a little apostrophe, is sometimes used to identify image points. So if I were to take triangle JKQ and translate it, well, I'm doing a translation here, but if I were to do any sort of transformation, the new triangle would be called J prime, K prime, Q prime, and those apostrophes are pronounced with a prime. So notice that you list the corresponding points of the preimages and images in the same order as you do for the corresponding points of congruent or similar figures. So our first transformation, there are 4 that we will learn in this chapter. Our first one is a translation. And a translation is just a transformation that maps all points of a figure the same distance and in the same direction. Some of you have known translation maybe as slide. Okay, so when there's transformations, the translation is also known as a slide. So you write the translation that maps ABC onto triangle A prime, B prime, C prime as a capital T, which stands for translation. Translation of triangle ABC into triangle A prime, B prime, C prime. A translation is a rigid motion and has some of the following properties. Okay, so here's my first practice problem. It says, what are the vertices if I were to translate this triangle -2, -5? So what does that mean? So essentially this is the X, this is the Y. So what it says is take each point and move it -2 in the X direction and -5 in the Y direction. So when I move negative in the left direction, I go 2 spaces. So let's start with point R. I'm going to move point R -2, 1, -2, and -5 in the Y. 1, 2, 3, 4, 5. -2, -5. So now this is the point R prime. The next one would be Q. I'm going to do the same exact thing. I go 1, 2, -2, down 1, 2, 3, 4, 5. That's -5, and there gets me Q prime. And then I'll do the same thing with P. I'll go -2. Oopsie, I want to do that in a different color. I'll go 1, 2, -2, and then down 1, 2, 3, 4, 5, -5, and there is P prime. And when I connect my new lines, or my points, here I've created an image of my pre-image triangle. Okay, what are the vertices of a translation of 1, -4 of triangle ABC? Copy ABC and graph its image. So another way of doing this is that what if I were to, instead of just plotting it, what if I were to just do this? So point A is at -2, 2. Point B is at 1, 1. And C is at 0, -1. So to find A prime, B prime, C prime, and again I use this arrow notation, okay, I'm just going to do what it says here. So it tells me to add 1 to my x, subtract 4 from my y. So -2 plus 1 is -1. 2 minus 4 is -2. B prime, you add 1, subtract 4. So if I add 1, I end up at 2. Subtract 4, -3. Add 1, subtract 4. So then I'd be at 1, -5. Now I can't graph these because there's not enough space, but this is the whole point of how you can, just been given points, how to show me what the new image points would be. Last vocabulary word, a composition of transformations is a combination of 2 or more transformations. In a composition, you perform each transformation on the image of the preceding transformation. So in a composition of transformations, if this is ABC, and I were to translate it over here, this would now become A prime, B prime, C prime. And then if I wanted to translate that again, I wouldn't go back to the original. I would start from this one, and then I get A double prime, B double prime, C double prime. So in a composition of transformations, you do something twice. Okay, so let's just take a look at our little lesson check here. Do you know if triangle JPT is transformed as J prime, P prime, T prime, what are the images of P and TJ? So the images of P would just be P prime, and the image of TJ would just be T prime, J prime. Copy the graph at the right and graph a translation of -3, -4. So I'll do this with just a couple of points. So that means go 3 to the left and 4 down. So if I went to I, I'd go -3 on the x, 1, 2, 3, and 4 on the y, 1, 2, 3, 4. And there would be I prime. And I can't do it with any other points because I would run out. That just means to go -3, -4. And lastly, point H moves 12 units to the left and 4 units up. What is a rule that describes this translation? So another thing that we need to just know is that there's a bunch of different ways to write translation rules. Okay, so if I wanted to say 12 units to the left and 4 units up, there's another 2 ways of writing it. So they gave me the words. Another way to write this is just to be a translation, and we use these little like less than, greater than symbols. If I go 12 units left, that means I'm going -12 in the x, and 4 units up is a +4 on the y. The other way you could write this is with XY notation. So one way to say is that take your x value and subtract 12, or take your y value and add 4. So these are the 3 different ways to write translation rules: with words, by the regular, just the XY note, just with the XY notation without the XY, and with the XY. All right, that's all from me.